Thank you. I have to say this is a little unnerving for me because I really am still just a farm boy from North Dakota. And I really didn't grow up facing this kind of an audience. But here we are. I love the prairie, and most of what I've learned, I learned in the prairie and with the prairie. And so my responsibility today is to share with you some thoughts about transforming agriculture. So why would we consider transforming agriculture? And of course, there are many people in our culture that would argue that it doesn't need transforming because it's really doing just fine, thank you. We are often told it's the most efficient agriculture system in the world, that it has removed the specter of famine, which we were considering being a most serious problem in the 18th and 19th century, that it provides us all with cheap food, which incidentally I would argue is a misnomer because in this country we spend more per calorie of food than 95% of the rest of the world's population. But nevertheless, because we spend less of our disposable income on food than any other people in the world, we're told we have cheap food. Never mind the fact that we have more disposable income than anybody else in the world. And that a new generation of technologies are coming along which promise even better times ahead. But there's another part to the story, and that is that farmers all over the world are going broke. They are not able to recoup now the cost of their production. And rural communities are dying, partly because farmers are going broke. The food which modern agriculture produces is now increasingly unsatisfactory to a growing number of people. And I would argue that it's simply not suited to meet the challenges that face us in the future. But there's a second question when we ask about transforming anything, and that is, how do we transform it? What's involved in changing a system like agriculture? And many of us, I think, are still sort of operating out of the notion that if we just all really get together and get organized and we flex our muscles, then we'll be able to get the kind of agriculture that we want. But as Wendell Berry reminds us, history doesn't give us very encouraging news in terms of that kind of an approach to transforming anything. And so when we really stop to think about it, and Kenny mentioned earlier this morning Jared Diamond and his wonderful book, Guns, Germs, and Steel. And one of the things that Jared Diamond, I think, provides us with is some clues about how changes actually really take place. And he approaches it from the point of view of simply asking the question, why is it that some societies flourished throughout the history of human civilization while others perished? What was the difference? And he concluded, based on his study of all of these civilizations, that there were two main things that were different. Those societies that flourished were societies that had been able to assess their current situation, anticipate the changes that were coming at them, and getting a head start. The societies that perished were those that failed to assess their current situation correctly, did not anticipate the changes coming at them, and therefore did not get a head start in terms of dealing with them. Now, I think that's an important lesson for us because it tells us that perhaps major changes in our culture, major transformations come not so much because we gear up and flex our muscles and decide that we're going to change them, important as that may be. But they happen because of a confluence of events that take place, changes that take place that are really beyond any of our control. And then if we take advantage of those moments in our history, we sometimes have the opportunity to move things in the right direction. This is from Iowa, and it's sort of a microcosm of part of the problem that we're facing in agriculture at the farm level. And if you notice here, the difference between the gross income of farmers in Iowa and their net income. And what it's telling us is that while farmers have been enormously successful in increasing productivity, they've done it at a cost which has not enabled them to retain the value of their own production. And we've done similar studies like this in other states and in provinces of Canada and Australia, and it's the same all over the world. I think that as we think about what are the changes that are going to be coming at us that we need to pay attention to and get a head start on, we've identified at least 7 that I think are going to be important in terms of agriculture. And I'm not going to spend a lot of time on these because I want to get to some good news here in a bit, because there are actually a lot of things happening in agriculture, and I would argue the transformation is already underway. But let's just look at these 7 challenges and look at them in terms of a confluence of events that will be taking place in the next decade or two that I think will provide us an enormous opportunity to transform agriculture. My point is that agriculture will change in the next 2 decades. How it changes, the major direction that it takes, will to some extent be dependent upon whether or not we anticipate those changes correctly and get a head start on moving in the right direction. The United Nations now predicts a global population of about 9.3 billion people by the year 2050. So a question which we need to ask ourselves is, as the population is growing in the poorest parts of the world, where incidentally often also the greatest biodiversity exists, how is inventing new technologies to enable farmers in Iowa to raise more corn and soybeans going to deal with that problem? It doesn't address it, of course. Almost half of the world's people now live on less than $2 a day. And there's no way that growing more wheat in North Dakota or more rice in California or more corn and soybeans in Iowa and Illinois is going to address that problem. It's a different kind of challenge that we're going to be facing. And at the same time that those challenges are coming at us, the very resource that we have used to fuel our modern agriculture, namely fossil fuels, is now in a state of depletion. And when we say fuel our modern agriculture, we're not just talking about the diesel we put into our tractors. We're talking about our fertilizers, which are almost all based on fossil fuel. We're talking about our pesticides, which are almost all based on fossil fuels. We're talking about our farm equipment, which use fossil fuel to manufacture them. So how do we begin to think about an agriculture in which we need to increase productivity, but on a more dispersed basis throughout the world, so that people actually can feed themselves instead of part of the population trying to feed the other part of the population? And doing that at a time when the very energy resource that has given us our increased productivity over the last 50 years is in a state of depletion. Food security is not simply a matter of this recent issue of a concern around bioterrorism, but the fact that we are now a global community means that we are much more aware than ever before that there are actually people like ourselves who don't have food to eat each day. And so gradually there is this emergence in our culture that maybe food ought to really be considered a right, just like any other right that we have as humans. So what kind of agriculture can meet these challenges at the same time that we become aware that food really needs to be a human right? And then, of course, we have environmental degradation. One of the other side effects of our successful modern industrial agriculture was, of course, that it has caused enormous environmental damage, and the environmental sinks are now full. 25 years ago, farmers in Iowa didn't have to worry that much about excess nitrates. But now there's an 8,200 square mile hypoxic zone in the Gulf of Mexico. And Louisianans in the fishery business are quite rightly saying, wait a minute, you got to stop the flow. And 70% of the nutrients flowing down the Mississippi River come off of farmlands in Iowa and Illinois and Minnesota and Wisconsin, Missouri. And then, of course, there's the issue of climate change, which we've already heard about today. We're not even sure exactly how climate change is going to affect our capacity to produce foods in various parts of the world. But a group of scientists at Iowa State University have done some computer modeling to try to understand how it will affect Iowa, part of the heart of the breadbasket of America. And the computer model is indicating that Iowa will probably see a 21% increase in precipitation. And most of that precipitation will come in the form of more violent storms instead of gentle rains. And therefore, we should expect that by the year 2040, we will see a 51% increase in surface runoff. Now, I don't see any way that we can continue to have 92% of our cultivated land in Iowa in corn and soybean under those circumstances. We've already lost 50% of our soil, most of that in the last 40 years. And even though we have now, through good management practices, slowed that erosion of soil down to 5 tons per acre, but that still means an inch of soil every 33 years. And if you add a 51% increase in nutrient runoff, there's simply not going to be any soil left for our grandchildren and our great-grandchildren. And then, of course, we have the issue of unprecedented explosion of infectious diseases, 35 new diseases in the last 30 years on this planet. And this past summer, a group of scientists got together to try to figure out why this is happening, and they identified 13 causes. And almost all of those causes were related to ecological impact. And of course, as we all know, agriculture is one of the major players in the ecological impact on our planet. So what kind of agriculture can we transform to that deals with that issue? So if we were to summarize this into a kind of a summary statement of the challenge that we're facing in the future, here's probably what it looks like. What kind of agriculture can meet the requirements of an exploding human population in the face of entrenched poverty in a post-fossil fuel era that must restore the ecological health of the natural resources on which agriculture depends, all the while that climate is changing, global society insists that food is a human right, and increased infectious diseases require that we attend to the ecological ramifications of our human activities. And I would argue that modern industrial agriculture is not designed to meet the challenge. So how should we now approach the future? Well, a couple of very, in my view, genius agroecologists from Japan, in a book which they edited a couple of years ago and wrote the opening chapter, raised a very interesting question, and I think it's probably the central question that we need to ask as we think about agriculture of the future. Here's what they wrote. Is it possible to replace current technologies based on fossil fuel energy with proper interactions operating between crops, livestock, and other organisms to enhance agricultural production? If the answer is yes, then modern agriculture, which uses only the simplest biotic responses, can be transformed into an alternative system of agriculture, which I would call postmodern agriculture, in which the use of complete biotic interactions becomes the key technology. Now let that just sink in for a minute, and let me go quickly now to 4 models that I think begin to take that kind of notion of the agriculture of the future, the complex biotic interactions, which they become the key technology. The first of these is actually my favorite. He's a young farmer in southern Japan by the name of Takao Furuno, and he's a rice farmer, or at least was. And he was a modern industrial-type farmer up until about 1987. He was producing huge quantities of rice, but he started to realize that, every year, everything that he earned had to go back into producing the next year's crop, which also ate up everything that he earned. And he was just, this was just not fun anymore. And so he began to wonder whether there was anything that he could do differently. And then he remembered that generations ago, Japanese farmers used to have ducks in their rice paddies, and he began to wonder what that was about. So he decided to find out. And he got himself a piece of electric plastic fence, put it down in the middle of his rice paddies, and put in some little ducklings, and just sat back to watch. And one of the first things he noticed, that these little guys were starting to eat the insects off of his rice plants. And so he began to wonder, well, if I had enough ducks in my rice paddies, would they eat all of the insects, and I wouldn't need to buy an insecticide anymore? So he started to experiment and found that, sure enough, about 200 ducks per hectare takes care of the insect problem. And then he noticed that as the ducklings grew and the rice plants grew, the ducklings were diving down into the water to eat something. He was wondering what that was about, and he started to look, and here they were eating the golden snails, which often attack the root zones of rice plants. So they were solving 2 problems for him. So then he thought, well, this is kind of neat. I wonder if there's anything else I could do. And he remembered that traditional farmers used to raise fish in the rice paddies, and then when they started using an insecticide, of course, it killed the fish, and he couldn't do that anymore. So now, since he's not using an insecticide anymore, could he go back to also raising fish? And the experts said, wow, you got to make a choice, Takao. You can't do both ducks and fish, because the ducks will eat the fish. And so he said, well, let's find out. So he got himself a tub of water, and he filled it with water, and he put little fingerling loaches into the water, and then put the ducklings in, and sure enough, the ducklings dived down and ate the fish. But then he thought, there's something's a little different in the rice paddy because the water is cloudy, and would the ducks still eat the fish in cloudy water? So he got a couple of hands full of soil, put it into the water, and stirred it up, put the fingerlings back in, put the ducklings back in. Ducklings didn't eat the fish anymore. So he thought, well, maybe this can work. Let's try it out. So he started experimenting, and sure enough, it's not a problem. He can raise both ducks and fish. Now something else started to happen. You'll notice that green layer of growth on the surface of the rice paddy. Well, that's a plant that farmers call a paddy weed. It's a fern-like plant that grows sort of like a water lily. You start out with one plant, and then you got 2, and then you got 4, and then you got 8, and you got 16, and pretty soon the whole surface of the water is covered, and it chokes out the rice plants. So farmers routinely use an herbicide to kill the azolla. But now, with both ducks and fish in the rice paddies, they feed on the azolla, so they keep it sufficiently under control, so it's no longer a problem. But the azolla plant also produces nitrogen. So now, with the combination of the fertility from the nitrogen from the azolla plant plus the manure from the ducks and the fish provides all the fertility that he needs. He doesn't need to buy fertilizer anymore. But now, Takao Furuno isn't just a rice farmer anymore. He's actually a food producer that produces off of that same acreage from which he once only produced rice, is now producing duck meat, fish meat, duck eggs, which he also harvests, and rice. And because he no longer uses an insecticide, he can now once again grow fruit trees on the periphery of his rice paddies, and so he's also producing figs. Now let's go back to the challenges for a moment. Instead of trying to do everything you can to simply increase the yield of a single crop, he is producing a whole range of commodities off of the same acreage, which is actually producing much more food than he was with the single commodity. But then something else he's noticed started to happen. His rice yields have now increased by 20 to 50%. So what's the equivalent for California? What's the equivalent for Iowa? What's the equivalent for North Dakota? Well, they're going to be different equivalents because we all live in different ecologies. But we all have the same rich, species, interactive, synergistic power that's given to us by nature. We haven't even begun to understand, let alone to harness in terms of increasing the food productivity and produce then, consequently, relatively well-balanced diet. The local people who eat from Takao Furuno's farm don't need golden rice because they begin to have off of that farm what begins to constitute a pretty well-balanced diet. Well, we've got our equivalent in Iowa, the Kuntz farms, and here are a couple of farmers that have started to experiment. And you'll notice here they're companion planting corn and grapes in the same field. And then they have decided, and if you look really close down and underneath, you probably can't see too good, but there's actually some chickens down there. And the chickens take care of most of the weed and insect problems in the corn and the grapes, and they also forage on any grapes that fall off of the trees so they aren't in the soil to produce potential diseases. And then they discovered that actually pheasants are actually better foragers than chickens are, so they have now gone to including pheasants. And then those corn cobs that don't make good food because they may have some kind of deformity or whatever, they become food for the pheasants, so the pheasants take care of them so they don't have to worry about any of the waste. This begins to ease some of the boundaries between tame and wild that in our farms, in our industrial farms, we have always insisted we got to keep everything wild out because it's going to be harmful to what we want to produce. And the Kuntzes are beginning to recognize that actually you can incorporate wildness into the farm, have that be part of your productivity. And incidentally, Takao Furuno also found that the ducks which are a cross between wild and tame ducks actually make much better foragers than totally domesticated ducks. Another example from Iowa is Francis Tickey, who is a dairy farmer. And he's made an interesting change in his farm. He's actually done the reverse of that wonderful article that Michael Pollan wrote a year or so ago, in which he said that in modern agriculture, what we essentially have done is turned a pretty efficient solar-powered ruminant into a fossil fuel machine. And Francis Tickey has actually reversed that. And he is using Jersey cows, which are much more efficient grazers and actually have a higher quality of milk. And then he includes chickens in his farm, primarily because the chickens eat the fly larvae, so he no longer needs to use an insecticide to control the fly problem in his farm. So there are the chickens in their little house, which he can move out into the field wherever the cows are. And there are the cows grazing on lush pastures. They get very, very little grain. They don't need to. And consequently, the quality of the milk is higher and has more CLA, all of that good stuff in it. And there are the chickens doing their job, eating the fly larvae and spreading the manure and all of the good things that chickens do. And then, of course, the other thing is that Francis Ticky lives next to this wonderful community in Fairfield, Iowa, one of the satellite outlets for this conference. And if you go into the stores in Fairfield, Iowa, it's Francis Ticky's milk that dominates the shelves. Now, there are farmers all over the world that are beginning to move in these kinds of directions, and Dan Imhoff actually has done a great service by pulling together a group of stories of farmers in the United States, farmers all the way from Maine to California and from Florida to Washington State, who have converted to these kinds of operations. Here is a metaphor for agriculture that we need to consider seriously. Instead of forcing nature to give us what we think we want, we ask nature what it is that it's producing and then turn it into something valuable and delicious for us to eat. And I think it's a metaphor for the future for agriculture. So my time's up, so thank you. That's part of the transformation of the future of agriculture. Thank you.